Welcome, everyone. My name is Daryl LeBar. I'm filling in for Julie this afternoon, or this evening, or this morning, wherever you happen to be. And welcome to the XRM Virtual Meeting with Jason Latimer, Why You Really Need Azure Functions. This meeting is being recorded today, so if you want to refer back to it later, you can. You can watch the XRM Virtual account on the Twitter account to see when that actually gets posted, but it will be posted and available for download and sharing to those you'd care to share with. Speakers. We are always looking for speakers, or we also always looking for concepts or topics to speak about. So if you are wanting to speak, it's a great place to get started. First time I did any sort of public speaking was for XRM Virtual. So if you have something you'd like to speak about, or you have a topic and you want us to present, we can always find a presenter for you. So feel free to either contact Julie at the email address below, or just ping the Twitter account, and we will be happy to get with you. The next XRM Virtual Meeting will be June 6th at 9 a.m. Pacific with Chris Cogna. I'm talking about IFT deployments. July 11th, we'll be building Dynamics 365.NET applications with IDEOX Connect framework. And then if there's anything else that you're interested in hearing about, again, we are always open for new topics. There are a few conferences coming up. Take note: Inspire, Ignite, Envision, and also the CRM-UG Summit in Nashville. I will be at the CRM-UG Summit in Nashville, so if you want to say hi, feel free to stop by. And if there are any others that we should know about and put on our radar, please let me know. Again, the XRM Virtual Twitter feed is probably the best way to let me know. And with that, I'm going to introduce Jason Latimer. He currently works for PowerObject and has been doing dynamic CRM work since version 1.2. and has performed the full spectrum of technical duties from installation to custom development. He primarily focuses on extending CRM to meet the needs of the customer. You can find him on the Dynamics community, on the CRM-UG forums, and occasionally putting together some helpful tools on GitHub. He is the developer and creator of the Dynamics CRM developer extensions, the CRM Rust Builder, and several other workflow utility libraries. And with that, I'm going to hand it over to Jason. And Jason, you're still muted. And you're not.
Yep, working on it.
Yes, we are recording.
Yeah, I'm looking. All right, let me know when we can see this.
I see it. PowerObject's an HCL company.
All right, there we go. All right, so here we are. Thanks everybody for attending. So really what we're going to talk about today is this concept of Azure Functions, or AKA serverless computing. We'll go through some examples of how to build stuff in Visual Studio or Visual Studio Code. We'll talk about some of the pros and cons you can do with Azure Functions, some of the other cool stuff you can do with them other than just, I guess, necessarily executing code. And hopefully, if I don't go over, which I always do, we'll have maybe a couple minutes at the end for questions. So there's just my information, if anybody didn't know already. The slides and all this samples should be, I do have them on GitHub, so there'll be a link at the end, so if anybody wants any of this stuff, it'll be available. All right, so what is serverless computing? So it really, the focus is on just deploying code and not necessarily worrying about, again, configuring IIS, configuring, firewall, stuff like that. So again, using a cloud service of some sort, there's, obviously the Microsoft version is Azure Functions. Amazon's got its Lambdas. Google has what they call Cloud Functions. All basically the same concept of these back-end things as a service to execute a little bit of code. Not necessarily a full application, but just something that you would typically use on not really a regular basis, but just something infrequently. So just kind of again pros and cons of using this kind of serverless execution model. So again, pros, typically you're only paying for, and this is kind of generalized. This part isn't necessarily specific yet to Azure Functions. So again, pros are typically you're usually paying just for execution time, and some of these probably have asterisks by them, just mind you. But another good thing, faster development. That kind of comes with the idea that you're really not developing full-scale applications. You're writing a function or two just to get accomplish one simple task. Being able to deploy it quickly, either through manually or through some sort of CI integration. Typically multi-language. Most of the vendors support not necessarily just their preferred language, but they'll support a wide variety of things to try to get that cloud business. So the bigger ones like auto scaling. So the idea here is with functions, you don't have to worry about manually scaling out. Like if you have a website, like in Azure, you have to go and configure that or configure auto scaling or something like that. This is the idea is if the service gets hit with a large load, the hosting provider will just scale up automatically and handle it, so you don't get stuck in a scenario where you're didn't have the foresight to scale out or do something like that. And then typically multiple triggers. So it's not necessarily things like timers and HTTP requests, and as you get into the Azure specific ones, you'll see there's quite a bit of things you can do with it. Obviously cons. If you go with the Microsoft flavor, you're kind of stuck with their model. You go with the Amazon flavor, you're stuck with their model. Transferring between vendor to vendor, certainly you can lift the code out in a lot of cases, but kind of the implementation is really kind of specific to that vendor. Server access, of course, being a hosted solution, just like CRM, you can't get at the web server, you can't do any of that stuff. So if there's something you're making that would require that, maybe this isn't the best solution for you then. Execution duration, kind of another thing. These aren't necessarily designed, again, to perform those long-running processes. This isn't the thing you're going to replace your plugin creating 800 records with necessarily. It's typically the shorter durations, 5 minutes or less. Once you start going beyond that, then we're again looking at a different kind of solution. Performance, I put that down because typically the idea here is when you're paying only for resources, really behind the scenes what's happening is when you need to use that service, it's spinning up the instance, albeit rather quickly, but again there's still some lag time. It spins up the instance, the code gets executed, then after a short period of time, if it's not used again, it spins it back down. So in effect, almost like that time where if you deploy an application on IIS, like a .NET recording or .NET application, the first time you hit it, it's really, really slow. Obviously not quite that bad, but again, if you're looking for something high performance, again, maybe not the solution for you. Debugging, again, running code in the cloud, debugging can be a challenge, although as we'll get into later, the Azure Functions actually have a fairly good, fairly good story for debugging some of this stuff, so that's good. Obviously, what are the things that we would even use Azure Functions for? So again, kind of your typical, APIs. We a lot of times we'll think of like an API application. Well, if you're not, most of us are probably .NET folks. You'll spin up nowadays you spin up like a web API project and you build that all out. That's fairly easy, but again, still kind of a lot of overhead. If it's just something you need to, again, a small bit of code you need to expose, maybe internally to your own company, maybe to vendors, probably maybe not necessarily for public consumption, but again, smaller scale APIs is probably a good fit. And centralizing, like if you have a certain, maybe some business logic that you need to share between applications. Obviously you could replicate it between all the applications, depending on the implementations, or if it's, again, the application can make an HTTP request, and you can, again, get out to the public internet or wherever the hosting provider is. call the Azure function, call the function with the common logic, and use it in multiple different consumers. Then more on the kind of the Microsoft side, using Azure Functions to fill in holes and things like logic apps or flows or power apps, to perform, make tasks easier for these. Especially when we talk about the flow and the power app side, these are meant more for the power user, not necessarily a IT developer crowd. So those are the folks that are have a little bit of idea what they're doing, but again, they're not going to know how to consume RESTful web services and stuff like that. So we can do some stuff to kind of simplify consuming these in those types of applications. So now we'll talk specifically about from here on out about just Azure Functions related stuff. So again, we've got, as we'll see in a little bit, we've got the ability to create them online. When we log into the Azure portal in a little bit, you'll see we've got an editor in the browser. Probably the Monaco editor that comes out of Visual Studio Code. We've got to create functions, or we can do it offline with Visual Studio Code or Visual Studio 2015. And obviously, doing it offline gives you the opportunity to better debug what's going on. You're setting breakpoints, executing it locally, or in cloud debugging for Azure type stuff. Again, multi-language support for Azure Functions. We'll talk about that in a second. And the ability to use NuGet and npm packages. We'll talk about that as well a little bit more in depth later. Continuous integration. So again, if this is something you're checking into Visual Studio Team Services or Git, you have the ability to kind of set up a continuous integration to just publish those changes out to Azure right away. This other point about consumption versus app service plans. We'll talk about that probably a little bit more, but again, the idea that a consumption plan is again, you're paying only for the time the function is being used, whereas an app service plan, you think of more like a website where the thing's always running and you're always kind of getting billed for it. Cross-origin support we can turn on. So again, if you need that to consume from JavaScript. Open API Swagger definitions. This comes into play a little bit later on when we want to use these types of things in like flows, for example. And this proxies concept is kind of neat. We'll talk about later. All right, so here's the extent of my PowerPoint skills. Look, I made all of these little language things pop up like that. Yeah, it's terrible. But anyway, you can see just the support they have right now: JavaScript, C#, F#, Python, PowerShell, Bash, PHP. We're only going to be looking at C# and JavaScript today, so all these other ones, we'll take their word for it that they work. I'm sure they have samples out there somewhere, the starter kits, starter samples for those languages. So functions on the Azure side really have these concepts of a trigger, obviously, what's going to make your function run, and then things we can send to the function, inputs, of course, or output values, things we can return from the function. So on this side, we've got quite a few triggers. You can see we can manually execute a function if it's just something we need to run once in a while. Put on a schedule, we can do that. Probably, I think that one of the more common ones you'll find use for is, again, just making an HTTP get or post or something request to the endpoint that'll get exposed with the function. We can tie into things like blob storage, event hubs, service bus queues, and all those types of things. It looks like also on the bottom they're starting a preview for external files. So I think again that would tie into like using that data gateway, if anybody's familiar with that, where you can tunnel through to your local network from Azure, and I think monitor a file share. I haven't touched that, but kind of nice. So again, what can we send to it then? We've again, outside of HTTP request, of course, we can post text and whatnot and files in the body. Again, if it's hooked up to blob storage, we can act on those blob objects. work on table objects, document DB. I can file at the bottom, and the bot one is kind of interesting. We'll actually, I have an example of that working, which is kind of cool, I think. Again, things we can output to, pretty much everything we can, write to things in the service bus or different Azure storage mechanisms. We've got a couple other integrations here, like SendGrid and Twilio. Can probably have some usefulness, or push notifications through a notification hub, and then outputting directly to a bot service. So again, that's what we'll take a look at. It's not too much the bot side, just how we bind that message up. All right, so functions. This is kind of this function. Again, being a smaller bit of code versus something that we consider like a web job. Again, something like a more fuller application. Kind of what are the kind of comparisons? So we talked about previously, functions will scale automatically. So if gets hit with a heavy load, you really don't have to worry about it. Microsoft's going to take care of that. Or something like web job. Again, if you have to account for the scaling. So either set up auto scaling or go in and provision more servers or instances by hand. Functions can use the per use model, the consumption plan you can set up when you're creating these, or you can put it on an app service plan. Again, the app service plan can be shared with like a website or something like that you've already got running. At that point, if you're putting it on an app service plan, I'm not drilling too much into the Azure setup of this. So if when you set up this, you have the option to choose a consumption plan or the app service plan. So again, if you've already got like a website or something running, you could host your function on that same app service plan and not necessarily pay anymore. Because at that point, you're constantly paying for the app service plan as opposed to the consumption-based plan. You're just paying for the milliseconds it's being used. Development story, again, the Azure Function side, again, the tooling we have for Visual Studio 2015 is still preview and it's a little wonky. 2017 is coming, where something like web job is just more or less standard Visual Studio projects, and the Azure SDK has got all that stuff kind of right out of the box ready to go for you. Kind of some other little bits, functions, if someone makes an HTTP request to it, you can return a response. Do that with a web job, you can't really do that. Again, this consumption versus app service plan. So with a function, again, it typically has on the consumption plan, there's a 5-minute timeout, and if you go with like an app service plan, people have reported there's still, if it goes beyond that 5 minutes, there's still this unexpected timeout problem. So not necessarily, again, you want to put something that's going to execute for more than 5 minutes on. So that's when you maybe use like a web job or just some other technology. We touched a little bit again, cold start on the consumption plan. Again, that kind of spin up time when you're executing it. You're not supposed to get that if you're actually on an app service plan, more sharing with like a website or something, or just a dedicated app service plan. So the thing is always running, so that way you're not. Again, it should be pretty much instantaneous when you hit it at that point, regardless if it's been used in the last 10 seconds or 10 hours. And we have multiple different ways to authenticate with Azure Functions. I think there's a slide on that later, and then web jobs is a little bit more limited, but we're not really going to talk about that too much. Okay. This is kind of just lifted right from the Microsoft site. I guess the idea here is you get some free execution time. This is, again, based on consumption, and you see you're getting charged, 16/100,000ths of a cent or something per whatever they define as a gigabyte second. So again, point of it is it's fairly inexpensive to host these things, just then using consumption model. All right, so jumping into, again, what do we have to start building these types of things? So tooling is available. There's that link at the bottom right there. You can get these preview tools for Visual Studio 2015. The beta version of the 2017 tools is out. If anybody's on that yet, but it needs requires like the next like version, like 0.3 version of Visual Studio 2017, which is only in preview right now. So you'd have to install the preview of the Visual Studio update to get the preview tools, and it's probably not something you're going to do until the real versions are released, probably in the next month, I'm guessing. So what that'll give us, again, that tooling will give us, we'll get project and different function templates to start building out some of this stuff. Gives us the option to debug locally. So again, it also requires these command line tools that we touch on a little bit later. They'll get to, if you start a debugging session in Visual Studio, it'll prompt you to install them automatically if they're not already on your machine. We can use the Cloud Explorer. At this point, we can hook up remote debugging to what's actually deployed, and package management with NuGet. So when we deploy these things, we don't necessarily have to deploy any dependent assemblies. If they're on NuGet, the idea is we can reference that. We can make that reference, and then when we deploy our code, it will be smart enough to just pull those packages and put them in the bin folder where it needs to be. But at the same time, we do have the option to get direct access to the bin folder for this function. So if you've got something that's not on NuGet or something custom, you can still upload it manually and then consume it that way. You'll see when we look at the project structure again. I think this is kind of a con here, or a con maybe, or a consideration when we build our projects. The way, if you use the deploy the publisher out in the Visual Studio tooling, it'll want to publish everything in your app, in your project. So again, sometimes if you have multiple functions in there, you maybe only want to deploy one. Makes it a little bit more challenging. So it's really just a matter of how you think of how you're divvying these things up when you're developing them. IntelliSense support is quite honestly terrible. And there's ways around that, and we'll touch on that a little bit later on. But when we see the editor, you'll see it's not really, even though we pick a C# template, the IntelliSense is just kind of screwed up a little bit. And just little things like we can't just do add new item to add different CSX files we'll look at in a second. So it's, again, preview, I guess. What can you expect? But I'm sure the 2017 version will be awesome, hopefully. So we're not going to walk through creating a new project or anything, but it's really pretty simple. Once you install these tools under the cloud area under C#, you'll see again functions, create function project. Then we can choose the type of individual function we want to create, and we've got a bunch of templates already. And we want to get triggered from various HTTP requests, or again Azure storage mechanisms, manual or timers, things like that we can hook into right away, and it'll scaffold up the project for us so we're all ready to start coding. So before we look at the code, so just kind of a couple things to keep in mind. For a C# project, we're storing our code in these CSX files. And we can still reference a lot of the namespaces and things like that we're used to using. It uses, and some are included by default. So again, it's just more or less just like if you're writing a CRM plugin, you can depend on certain things being on the server. I didn't list everything. There's a list on the documentation so you can go and look for it. But again, system.net.http and stuff like that are all just deployed by default. So you don't really have to worry about that. You don't have to make any special references for them. Things like if you want to use JSON.net, for example, that's available, but we have to actually declare we're going to use it with this #r assembly name. There's another list of things that are kind of optionally available. And again, I talked about NuGet, availability. So again, if we have this project JSON file that gets created, we can put in, whatever, the NuGet package and the version. And the note here is, it's only three kind of minor major revision notation. So like again, CRM packages, for example, those will have the version or the build number as well at the end. So again, you pretty much have to omit that, and you'll probably get the latest one at that point, I hope. So just keep in mind 3 places, not 4. It came right off a CRM tip of the day, so you can go find that out there. Then again, like I said, you can get direct access to the bin folder if you just want to go ahead and upload stuff. So again, we have this. Every project will have this function.json file, and really what this is defining, again, what are the bindings for the function. So what's coming in, what's triggering it, are we sending anything out, how are we binding to the output of the function. We have options where we can just bind to the return value of the function, or we can do effectively a named variable we can bind to for output. Again, we can access that directly in code. This function.json isn't published with the rest of the function, so some of it is, you might have to go and configure it one time manually. And this isn't where we store any kind of usernames and passwords or anything like that. All right, so we'll look at this project right here. So I'm going to paste this URL in the chat window. Hopefully we can see that. This is just kind of a fun little thing. So this is the code. So okay, we'll come back to that in a second. 1 second. So I'll show the first example is just a simple geocoder. Again, nothing that really would require putting in an Azure function probably, or especially if you're using it like CRM, with the CRM context. Because you think of it in terms of the CRM world, this is a perfect opportunity to include, you have a third-party library you need to include in like a plugin, and you can't. If you can't IO merge it, then what do? This is kind of a good way to kind of solve that problem, where here we can create an Azure function just to fill in hopefully provide that one little bit of code that relied on that library perhaps. We can deploy that library without any issues. Then from our plugin we can just make an HTTP request to our function service. It'll do its thing, it'll return the data, plugin can go on. Obviously, there's going to be a little overhead in that type of model, waiting for the request and response to happen. But what can you do at this point? All right, so just kind of taking a look at this one. So real quick, so this function JSON file, and this is you can take a HTTP request in of a post. In this case, we're going to post like the address, and then we're going to provide the output of latitude and longitude. So in this case, I've got a class defined for the input and output. This is going to bind to the return object of the function, which is what this $return represents. So again, just our simple input. We're going to expect address 1, 2, steady state zip, etc. When we respond, we've got this pre-crafted response class of just latitude and longitude. So everything will go and start in this run.csx file. And so we can kind of take a look at a couple things right away. Again, for those libraries that are kind of available, but you still have to make a special reference, we can $R and whatever the reference is, we can put that in there. If we want to split our code out, so in this case I've got my main run file, but then I've also got these other class files. We want to include those, we can just use $load, and then kind of the again, relative path, if you have folders or whatever, to the file, so that way they're available. We've got built-in logging, so this will log to the console in the function on Azure we'll look at. So just to kind of show you how the IntelliSense kind of doesn't work. So you would think if this was like normal IntelliSense, I'd be able to type log and then get the .info method off of it. So if I start typing log, control space, then what do I get? I get what just happened there? It doesn't recognize log as a thing at this point. So development story with these templates is a little not so great. So I'm not going to really go through the logic of this. That's not the important part. It really just calls like the Google geocode service, sends the address, gets back latitude and longitude. No real big deal there. So let's hop over to the Azure portal. So again, we can see now I've published the code, so it's the same code that we see in Visual Studio. This is an editor, so if you want to go in and start changing it, you can totally do that. Again, IntelliSense isn't really any better here, so but you can change it here. Also has the kind of nifty ability to test right in the console here. So again, I've got mine configured to work on a post. I've already formulated my JSON that I want to send to it with my fields. So I just run it. You can see it output our latitude and longitude, so we can get a pretty good idea it's working right away. Let's hop through a couple things on here real quick. This integrate is where we can kind of define our triggers. So you can define if it's only bound to certain HTTP methods, for example. And this is kind of important, setting some of this stuff up correctly. You could, if you just bind it to any HTTP method, that obviously could work. But again, when we get into generating like Swagger definitions, that becomes less helpful then. Define what our output is. So in this case, our output was the return value of the function. So when let's jump back over to that real quick. Oops. Where'd you go? Okay. So here's where we kind of our entry point, blah, blah, blah. We go through it. So, right at the end after we've retrieved the latitude and longitude, I'm just creating basically my HTTP response, converting it back into that format, sending it back as JSON, and then just returning this HTTP response is the functional result. And that is where, again, our that marries up to, again, the output of our function definition. All right, so again, this is managed as we kind of manage our different keys for the function if we're putting some sort of authentication on it. Again, monitor, there's a bunch of actually it's the function level. Okay, so moving along. So that's fairly straightforward. Again, we can deploy. Again, if we right-click on our project, we can publish, and this is kind of the I guess the standard Azure publishing feature. But again, it's going to publish any functions you have under your project. So in this case, it would publish this geocode. It would also publish this other one I have. So okay, that's the first demo. So let's close all these out. All right, so this is the second demo, was the one that's using the bot. So this isn't a bot demo, so we're not going to go into that. But just the idea is I was playing around with the newest functionality with the bot service that's kind of new in Azure as well, and checking that out. So I kind of thought I'd incorporate it into this demo. And it kind of worked a little bit better when I actually presented this talk in front of people, because actually the idea is it's going to we're going to use the bot to create a contest entry. And then we're going to combine this with a Microsoft Flow and use an Azure function to choose the winner, and then return it back to the bot. So, and just again, bot message is just again it's just a class. Function definition, again, input we're taking. This is basically just we're taking a GET at this point, a GET request, and we're binding at this point to a bot type. Instead of like HTTP, we're binding to this bot. Can use just the function output. We have to specify which bot and stuff that it gets used in, and there's a key that you have to assign to this, which we'll kind of touch on at some point where that goes in the configuration. So The idea really is it's really not to. So how about we do this? How about this? So does everybody see the link I put in the chat window? I hope everybody can see that.
They should all be able to see it, and I see it.
Okay. Okay. So go to that. If we go to that website and just kind of type in some arbitrary something or another to get kick the bot off. It's going to prompt you for your name. That's going to ask you, okay, what type of cell phone do you have? Hopefully everybody can do this, by the way. This is encouraged. I'm just going to want you to confirm that. So it's just saying, okay, we're confirming your entry, etc. Hey, we've got it. So keep this page open. So what this is basically just doing, it's just recording this information in the Azure Table Store. It's for a storage mechanism. So then the idea is I've got so again, I've got a Microsoft flow that we can use to execute this function. So if we just kind of look at the definition. So my manual trigger at this point, and I'm just using it in the function. I'm using in the HTTP step, just using a GET. And at this point, so when we generate a function, it's going to have a URL assigned to it. This is kind of the root of it. In this case, I've got a functional level authentication, which is going to assign a key as well. Again, this is my key. I can pass that in the query string, or I could send it in a header as well if I wanted to. So in this case, it's not really looking for anything else. It's just, again, I just need to put a GET request against this URL is simply what it's doing. So this was cooler when I did it in front of people because I actually had a prize to give away. So this is not going to be too exciting for anybody. So I can run this. There's really nothing to input there. So the idea when we go back to our bot page, so I just said, okay, where is Mr. Colin with an Android phone? So sorry, I don't have a prize for you, unfortunately. You can pat yourself on the back. How about that? No, I'm just kidding. So the idea is, okay, so my output of my function was back to the bot. So it just kind of shows some of the power of what you can do with some of the stuff. You can run, I think, entire bot platforms on on functions. Again, my bot is just backed by like MVC Web API application. The code's going to be all up on GitHub, so nothing too particular. But the kind of the idea was I had these screen beam things I had gotten. They don't work on Apple phones, unfortunately. So the idea was this is filtering out when it pulls that table out, it pulls the winners out of the table, and automatically drops anybody that's got an Apple phone, and only picks a winner out of the Android and Windows Phone users, because that's where the thing only worked on. So the deck was kind of stacked against those Apple people like myself. But again, request comes in. We've again nothing particularly special. Again, we can kind of standard kind of Azure APIs. And this is again this get environment variables. Now this is where we have my key for my API key for the storage account. So if we at the function level, again we've got some more options for kind of globally for our functions. We've got the settings. Where is it? Okay, platform features, application settings. By default, scroll this down. There's a bunch of them that get created by default, but we also have the ability to put our own values, our own key value pairs in here. So in this case, I had a connection string to my storage account. I can give it a name and then use that syntax to retrieve the value. So that way, I'm not storing secrets anywhere, and then not getting into source control, things like that. So that's if you're needing to manage that type of stuff, this is the place for it. But again, hopefully you're not needing to manage that in any kind of automated fashion. This is where we can start getting into. Again, we can go to these consoles. This is where we direct ourselves to the bin folder if we go into this app service editor. Slow. Circle back around to that. I don't want to get too far on the weeds here. All right, so we're not going to walk through this because we're running kind of short on time. So again, you can also use Visual Studio Code, and you can, if you're into that command line thing, you can use the command line tools to scaffold out projects as well with the human generator, and particularly there's an Azure Functions project generator you can use to scaffold the projects. So again, there's a link at the bottom if you're using those. Again, even if you're developing with Visual Studio, again, when you try to debug the project, it's going to prompt you right away. If you don't have the CLI tools installed, it's going to make you install them if you want to use that, because it really builds a virtual host on your local machine to run those off of. That's obviously the core of it. And again, really more for JavaScript-based functions. You can use, again, along the same lines of using NuGet, you can use npm, but it's a little clunky. It didn't appear to support auto restore once you deployed it. I actually had to go again to this. Again, here's my folder structure now for all my functions. There's also a console somewhere. I think it was back on screen, and there's a console you can execute commands. Actually, to do like an npm restore on this. Again, this other demo, I'm just using again moment.js to do simple date formatting. To restore that package, I actually had to go to this console and execute the restore command the first time for this to get populated. So it's I was kind of not expecting to have to do that. I thought it just automatically work like NuGet, but alas, it did not. So again, that console is located right there. So again, walking through setting up a project is again fairly straightforward. It more or less is kind of the same steps as the Visual Studio proper side. Really create your project, pick your language, pick the project type, and it scaffolds out a project for you. Again, fairly similar. Just everything kind of goes in an index.js at this point. And we've got a package.json file that kind of handles what our dependencies are. Like I said, we have to execute the npm install under manually for some reason. That would look like, again, we've got the function JSON, again, defines our definition. Something, and this is just a simple, again, HTTP request to GET request in. In this case, we're just going to send the date in the query string, and then output, instead of binding to the return, like output of the function, we're going to bind to this response variable. So again, really simple. We can see we've got the request coming in, request object coming in. I've got a date value and a format that we want to use. It just really just uses this moment.js to just give it a pretty format. And again, now our response under this context created the HTTP response. Basically is what this is doing with 200, succeeded, and just in the body of the response, it's going to send back our pretty formatted value. So see, just again, what would something like that look like when it got executed? So again, my test, my query that's getting executed, my GET request is just the URL, which by the way, you see it right up here. And again, run it. Again, very simply just formats the date. Nothing crazy. But the idea here is, again, you can use this for for CRM people. Use it for things you can't embed inside a CRM. 15 minutes. All right. So this is kind of this is, I think, where at least if you're doing it from like C#, F#, deploying functions. Now this is kind of the way to go. And so instead of using embedding your coding kind of directly into that run CSX file, this is where you basically just create another class library to embed your code in, and then reference it from your function project. So that way, again, whatever you're developing in your Your other class is, again, just full IntelliSense and standard development at that point. Should also run a little bit faster because, again, as you'd expect, what we're in the previous examples, we're just, again, at least in the C# version, again, we're uploading code, so every time it runs, it has to recompile. So at this point, all the bulk of the code would already be compiled, so it should run a little bit faster at that point. We can still debug locally. Again, still use NuGet. We can still publish the same. It really just requires a couple of changes to this function JSON file, so we know where to look for those files. Let's close those now. So again, I've got just a standard. I think this is built on a web application project. So the idea here was to kind of show again kind of another integration with CRM and in this case a logic app. So I've got a scenario set up where I create a contact record in CRM. I've got the kind of native service bus integration turned on where on the create of that contact record, I'll just push that entire context out to the service bus. So then the idea here is what I want to do is I want to get a copy of that contact in my Outlook contacts. So this is where it should be. See, it's easier said than done if you try to do it without help, because the JSON data that comes out of that's included in the service bus context message is quite complex. So again, if we create a contact, this is all the JSON data that gets sent along. We really don't have too much opportunity to trim that down, starting on the CRM side. So flows and logic apps, they do have, if you're familiar with them, they do have like a parse JSON step. But again, it starts to choke at this point. It's way too complicated. So the idea was create a function to again parse the JSON data into something a little more consumable. Take all these fields and just output the 4 file we actually need to work with. Again, just a couple classes. So this is basically the definition of that JSON I just showed you. Again, creating this was quite simple. I just paste the JSON. There's a edit, advanced. Where is it? Somewhere there's paste as JSON, and it'll automatically just create the structure for you. And it's slick, and it takes 2 seconds. Again, this is bound to. I've got my function. I don't have a function definition on this, and that's on the portal, but it's bound to, again, the queue, the service bus queue. So when that queue message comes in, oh no, this is actually not. I'm sorry. The logic app is reading from the queue, and this is taking out via HTTP. So I just go over to my logic app. So the logic app is bound to the queue. Execute. In this case, I've actually got a handy pre-configured step to call an Azure function, and this it'll recognize the functions that are defined in the resource group, I believe. And then once I've took the complex JSON and simplified it to just a few fields, I can easily parse it then. In this case, I'm just returning, again, simple things like city, state, first, last name, nothing crazy. Then I just, again, use this kind of built-in integration to Outlook just to create a contact. Code wasn't really, again, in this case, we're not going to get access to the code because, again, it's pre-compiled already. So I went to the, again, I uploaded the DLL directly, I think, to the bin folder on this one. So again, really pretty simple. I'm just taking my request, just creating deserializing it and pulling out the values I want and just turning it back into a response again. So nothing super fancy again, but again, the thought is to augment something for the power user or the less than power user that might be using a flow, for example. So just kind of see this in action. Create a So we'll save this guy. So we'll see, just look at our contact list. There's no Harry Potter in there yet. Back over, we should be able to see our logic app actually. See if it fired yet. This case. Oh, I'm still waiting actually. So hopefully that'll come through when the logic app decides it's gonna. Okay, so there's our Harry Potter just popped up in Outlook. So again, the idea is again, simplify the request. So instead of having to try to deal with all that JSON data directly, simplify it down to something consumable. Debugging, we're not really going to go through that because we're running short on time. But again, you can F5 in Visual Studio to start up the local version. Then you can use like Postman or something to just execute a request against like a local host, whatever, to trigger something, for example. There's other ways to trigger, simulate like Azure Storage and stuff like that. You can use, again, Cloud Explorer to remote debug. From the Visual Studio Code, you can use the command line tools to spin up your instance. Authentication, so again, just you can put a key on at the function level, for that, if that's appropriate. You can define it as functionality for admin level keys. So again, it'll give you there's an admin level key and a function level key. You can if you define it for admin level authentication, if you pass an admin key, it'll execute anything that's any functions. There's kind of one key for multiple functions, and it can also execute functions that are turned off or disabled. It just, I don't know, if you're trying to obscure it or something, maybe that's useful. Or of course you can make it anonymous if you want. And you can also, again, you can use kind of app service based authentication if you want to use like Azure, AD, Facebook, Microsoft, those types of providers, if that is appropriate for your flow. We kind of touched on again where the application settings area. So if you're trying to store keys and tokens and stuff like that, that's the place where you put them. It sounds like you can't do that with actually a direct like REST request or PowerShell or something like that. Some of them, I kind of ran into this situation where this bot framework it's actually it's looking for a token called exactly that. So again, if you had multiple bot functions pointing to different bots, you can kind of get into a little problem because that would kind of be sharing that same key value. I don't know. If you're debugging locally, you can create an app settings.json, which will simulate this request to that app settings area in the actual portal. Function proxy, it's just there's probably some uses for it. So the idea is you might have maybe a complex URL. In this case, think of the URL that got generated for this service, this geocode. It's not overly complex, but I've got the token in the URL. So, and maybe you don't want to necessarily expose that. You can create this proxy, which is basically just what URL you're going to use, kind of coming in, and it's going to really just forward it to whatever URL you specified here. So now I could call just simple geocode from my Azure site. It'll just pass through the values and send them to this the actual URL. So you can kind of obscure things, or theoretically you could put, I think you could put just about any URL in there. I don't necessarily think it has to be one you quote unquote own in Azure. So creating like Swagger definitions. So this is handy for if you're trying to create if you're trying to a custom API endpoint in Flow, for example. So if we back over to the portal here, we can go to this API definition area. So we've got the option to export it. So this will let us, we can take whatever it gives us, or we do have some ability to customize it, which is kind of escaping me where we did that. But by default, when I exported this one, it didn't really work all that good. I had to make some changes to the definition manually to get it to import back into Flow. So, for example, so we go into our settings. We have the idea we can create these custom connectors. In which case, I've defined my custom connector for some of my functions. I uploaded the Swagger definition file. You can technically point to the URL for it. Actually, the portal provides you one, but again, I had to make some modifications to it to get it to work. So at this point, it's going to now, once we save this, and then you can put security on it and stuff like that. It gives you the methods that are available for, again, this is kind of at the high level. This was the definition for all my APIs that I had available, all my functions. So it exposes those. You can kind of give some more context to each one as you go through it. So again, this geocode one, for example, pointing where it's going to. Again, I'm just kind of clarifying it's going to be a post. And this is, some of this is read automatically, so this is where I'm kind of defining more specifically what messages and stuff it responds to is helpful. So the idea is once you've defined all that stuff, so now if I'm, someone that maybe isn't, a little bit technically savvy, but again, they're not going to consume REST-based services. So now I can add an action, go to my custom service. This is exposed, what actions are exposed. So again, this really kind of simplifies it, so they're not necessarily having to make, create the, type in the text to make a JSON, request object. It just gives them nice fields. They can just map them to whatever else might have been in the flow, and then, very easy to consume for someone that doesn't really know what they're doing. That's it. I finished on time. One time in my life. So this is, if you want to download the slides or any of the code, it's all right there. Actually, I don't know if I can copy out of that. Probably not. And that is it. Does anybody have any questions, comments, concerns?
So Jason, what was your starting point for learning how to handle this stuff, or learning how to code in this stuff?
Well, I mean, the idea going back to, CRM Online, you can't do certain things. It's like this is kind of the, it seems to me this is something they need to build into the CRM Online platform. Mm-hmm. Maybe a more direct integration or some kind of, I don't know, that's probably what they'd end up doing. They probably wouldn't make like a special knockoff or anything, but some way for us to get around those scenarios where we need to, use those external libraries or something not provided, or doesn't really solve our problem of, again, plug-in execution timeout per se. That's kind of going more toward a, maybe incorporate that into a logic app. Then functions, of course, could be, called from the logic app, but the logic app isn't necessarily going to have like a hard 5-minute timeout limit. So if you need to do those bulk requests off a plugin, something like that's the way to go, not trying to cram it all in 2 minutes.
So Michael has a few questions there.
Yep. So really at this point, so if you want to use it from CRM, going back to a function, really it's just a matter of, we've got a URL. At this point, it's really just a matter of making an HTTP request from like your plugin or something like that to this URL, again, passing, whatever it's required, getting a response back and just dealing with it inside your plugin. Azure Functions connected to CRM. Yes. So I probably should have put, when I did this demo originally, it wasn't for CRM people. It was for other developers. But what you could do, again, if you're needing to talk back to CRM in your Visual Studio project, you can, again, just NuGet the SDK core assemblies or what have you. Write your CRM code, as normal. Again, you'd probably, at this point, if you're using that, you'd again probably be using like a username and password that you'd put in your app settings and retrieve dynamically. But at that point, it's really no different than if you write a console app or something like that. Just a matter of the trigger is again a timer. If you just run a job on every day at 5 o'clock, you can set up the trigger timer, run on a schedule, process it. Again, you could call it via HTTP request, or if it's just something a manual, you can just go in and push a button to run it whenever you actually need it. Again, then you can hook it to numerous other events. But again, really, it's just a matter of just use the CRM SDK assemblies and username and password. Theoretically too, you could probably the better way to do it is not quite as friendly, but if you're familiar with using server-to-server authentication now for online, it's really pretty slick. You'd have to hit the web API endpoint directly and just craft all your stuff manually. But if you set up server-to-server authentication, the user account you end up creating in CRM is this application user, and it doesn't consume a license, which is pretty awesome because nobody likes paying for those service account licenses. And the other part is you can create multiple application users and then assign them security roles, to limit their access down to whatever the API actually needs access to. Because let's face it, probably every person that has a service account talking in CRM, the account is set up as system administrator, and they probably have to because they have to reuse it and they don't want to pay for multiple licenses. So that's not exactly secure if those credentials leak. So the idea here is if you have these application users, you can tailor each one just to a subset of the data, create as many as you need. That way, if again credentials happen to leak, you're not quite as exposed. It's a little bit more secure. Why use Azure Function over Web API? So the question is why use an Azure Function over like setting up like a web app? Again, I'd say more the consumption. The web, like a web API, you're paying for that constantly. So as long as that, as long as the app service plan is in place, you're always paying for it. Thinking in terms of, you can set up a function in a consumption-based model, so you're only paying for those milliseconds it's actually called. So if you're, again, if you have this geocode function set up and you only need to call it 2 times a day, you pay like, a penny for the month or something, right, to have it, whereas having your own app service plan is going to cost, we're moving into dollars now at this point. Any other questions? Is there any way to avoid parallel execution of Azure Functions? I don't know. I never really thought about that. I don't think there's anything. There's really nothing to stop you from, executing this multiple times, because again, really the functions are made to be, stateless, as a rule. So they're not really talking to each other. You're not really tracking execution instances anywhere. So I think the idea is probably not. If you're trying to call it. Execute it, dynamically. If you need it running only once, I think that's where you're looking more of a model of some sort of manual or schedule-based trigger. That way, you're pretty safe that it's only running at one instance of it. Anyone else?
Well, Jason, thank you very much for sharing and going through all those examples. And again, this will be posted online for those of you that would like to refer to it later or refer to it to somebody else. And we hope everyone has a great day.